So the video I had y'all watch yesterday started talking about these here. So it mainly talked about the vertex form, right? Where we have an equation of a line in vertex, not line, equation of a parabola in vertex form here. A times x minus h squared plus k. So we had it in vertex form. Now the reason we call it vertex form is because the vertex is the point h comma k. H value, k value. It gives us the vertex. It tells us what the vertex is. And the axis of symmetry is x is equal to h. So when we have it in vertex form, it kind of gives us this information. So if we look at an example of this here, so we're going to do one of these here, and we're going to kind of move on to the next ones. Because this here we've done, or y'all have done, we've seen a video doing this already. A times x minus h squared plus k. So the vertex is h comma k. Well, we get the h value from inside the parentheses. Now inside the parentheses we have a positive 3. So that means the value of h is what? Negative 3. The value of k here, plus 4, so this is 4. Because when it's outside the parentheses, we just take it with the sign that's already there. So since it's plus 4, it's going to be positive 4. Now I'm going to abbreviate axis of symmetry, A of S. Now the axis of symmetry is x is equal to h. Well, we already found the value of h. So it'll be negative 3. Now we would have to graph it, but at this point with graphing it, well, I can find the vertex negative 3, 4. And the axis of symmetry is going to be the line along x equals negative 3. But you can also put it in the graphing calculator. Hitting y equals and then plugging it into the first one and hitting enter, having it graphed, and kind of matching the graphs up. And that's what I would do to really graph it, because it's going to give you 4 choices to pick from, 4 graphs. Use the graphing calculator and match it up. Okay? And that's going to be with all of the ones we looked at today. For graphing, use that graphing calculator to graph it and match it to the correct one. Questions on this here? We good with this here? Okay. Now we did several in this vertex form. Now, this here, ax squared plus bx plus c. This is what I call standard form. This is what most quadratics you will see them in. Ax squared plus bx plus c. Is going to be in this form here, what I call standard form. Now there's ways that we can relate A, B, and C to kind of our H and K with vertex form, but we're not going to worry too much about that. When we're given it standard form, the vertex is this right here. The vertex is this right here, negative b over 2a, comma, f of negative b over 2a. So vertex is negative b over 2a, comma, f of negative b over 2a. And the axis of symmetry is x is equal to negative b over 2a. So I'd circle that somewhere, because I'd circle that on your page, because that's what we're going to be using and utilizing, is that right there, that f, the axis of symmetry and the vertex. Now it works out the c value is going to be the y-intercept, whatever it is. It actually works out to be the y-intercept, because the x value of the y-intercept is 0. And when we plug 0 in for x, these 2 spots here will both become 0 and gives us our c. But that's just kind of a side point. So what we're going to look at is finding this vertex and axis of symmetry. I know it printed really small. I realized that after I printed them off. So I have to fix that next time. So on this here, like we did yesterday, the video yesterday, we want to find the vertex and axis of symmetry. So let's look at the vertex first. Now the vertex, it tells us it's negative b over 2a, comma, f of negative b over 2a. Yes? Because that's what it said the vertex was. Now, our normal function is ax squared plus bx plus c, yes? A, b, and c. So what matches up with a? 3, b would be negative 6, and c is 1. Because if I look at that there, ax squared plus b plus c, the a matches up with the 3x squared. It matches up with the 3. A matches up with the 3. B matches up with the negative 6. And C matches up with the 1. So the value in front of x squared would be the a. The value in front of x is our b. And the number without a variable is c. So we have a, b, and c. They can. I mean, it could be rewritten in a different way, because we could say negative 6x plus 3x squared plus 1. But it's still that there. Now, we will always want to rewrite it so that x squared comes first and then going down in descending order. But the number in front of x squared would be a, the number in front of x is b, and the number by itself is c. So any questions on how we found a, b, and c? We good with a, b, and c so far? Yes? Now, the vertex. The x value of the vertex is negative b over 2a. What's the value of b? Negative 6. The value of a is 3. So negative b over 2a, we plug in the value of a and b into their respective places. Now we simplify. Well, negative 6 is 2 times 3 is so the x value of the vertex is 1. Negative b over 2a. We plugged in the value of b, we plugged in the value of a, and simplified. Questions on this here? And that part there is not too bad. We can kind of see that, negative b over 2a. Now, probably the confusing part is f of negative b over 2a, yes? Because that second part of this looks a little bit more confusing. This part right here, yes? But what's negative b over 2a? 1, right? So really what this is saying f of 1. So what I'm going to do is I'm going to take this function here, and anywhere there's an x, I'm going to replace it with 1. So we're going to have 3 times 1 squared minus 6 times 1 plus 1. Now I'm going to move this down here so it's not over the top of the graph. So all I did is I replaced everywhere there was an x with 1, because we were saying f of 1, not f of x anymore. Questions on this here? Now we can simplify. Well, 1 squared is 6 times 1 is negative 6 plus 1. 3 times 1 is 3. We can do this here. 3 minus 5 is negative 2. Any questions on any of this here so far? Really, at this point here, if you wanted to plug that into the calculator, you could. So I have it written up there, but I'll rewrite it down here. So our vertex is 1, comma, -2, yes? So to find the x value, we just typed in or plugged in the values of b and a and -b over 2a and got 1. Then we took that 1 and plugged it into the function to find the value of y. And now we have the vertex. Now the axis of symmetry, x is equal to -b over 2a. Well, what is -b over 2a? There's the vertex and axis of symmetry. And that's all we have to do for this here. Now it's going to ask us again on the homework to pick one of the 4 graphs. You can type that straight into the graphing calculator, it'll graph it for you. Okay? I'd use the graphing calculator to do y equals 3x squared minus 6x plus 1, hit graph, and match it up. Now, we know what the vertex is, and the axis of symmetry is. Now, because the value of a is 3x squared, the number in front of x squared, since the value of a is positive 3, it's going to open up. If the value of a, the number in front of x squared, is negative, it'll open down. The value of a determines if it opens up or down, if it's positive or negative. Okay. So graphing it, really use the graphing calculator to do that. Because you could type this in, x squared plus 2x minus 1, hit graph, and it'll give you the graph for it. Now the vertex is -b over 2a, comma, f of -b over 2a. That'd be good to know what a, b, and c are. So Jared, could you give me the value of a? What's the value of it? So just 1, because it's a x squared plus bx plus c. So we're not so much worried about the x squared or x, but the number in front of x squared. Well, it's not written, right? So if it's not written, but it's still there, it's always 1. B would be 2, and c is -1. Now with these here in standard form, if there's a minus sign, it goes with the number. Minus signs and negatives go with the number. Okay, -b over 2a. So what's the value of -b? Or what's the value of b? A is 1. So we plug in 2 and 1 into this here. And then we can simplify. Well, -2 is just going to be -2. 2 times 1 is? And this simplifies to -1. So the x value of the vertex is. So any questions on how we got the x value of the vertex? So we good with that there? Yes, not too bad so far. So after we get the x value of the vertex, what are we going to do? Plug -1 in for the x. So I'd have -1 squared plus 2 times -1 minus 1. Yes? Well, -1 squared, -1 times -1 is 1. 2 times -1 is -2 minus 1. 1 minus 2 is negative 1. Negative 1 minus negative 1 is negative 2. And that's it. That's our vertex. So we can plug it in. Any questions on any of this here? Axis of symmetry would be what? X equals what value? Negative 1. Because it's going to be the same as the h value of the vertex, or our negative b over 2a. Now, one thing to be sure is you need, for axis of symmetry, you got to really write it as x equals negative 1. You can't just say the axis of symmetry equals negative 1. Because when we're talking about the axis of symmetry, we're talking about the equation of the line that would be coming straight down. So we have to have it as x equals. Are there any questions on this here? Do y'all need to see another example of finding the vertex and axis of symmetry from standard form? One more? Let's look at one more. Let's look at this one here. So, vertex is negative b over 2a, and we have f of negative b over 2a. Now we need to find what a, b, and c are. So here, what's the value of a? A is negative 2, b is negative 8, and c is 1. A, b, and c. It kind of matches up, it will, not kind of, it does match up with our ax squared plus bx plus c. Now to find the vertex, the first thing we need to find is negative b over 2a. Negative b over 2a. So we found our value of b is negative 8. So what we'll have is what? Negative 8 over 2 times negative 2. We're plugging in for a and b. Well, negative 8 is 2 times negative 2 is negative 8 divided by negative 4 is negative 2. And again, you can plug this into the calculator. Really, you could have plugged this here with the fraction, so negative 8 over 2 times negative 2 in the calculator, and it will have simplified it to negative 2. Any questions on this here? Well, at this point here, we could really say the axis of symmetry is what? X equals, because we already found that value. But we still need to find out what the y value of this is. So what do we have to do? We've got to plug it into the function. So we could say negative 2, parentheses, negative 2 squared, minus 8 times negative 2 plus 1. Well, negative 2 squared is 4. Negative 8 times negative 2 is plus 16 plus 1. Negative 2 times 4 is negative 8 plus 16 plus 1. Negative 8 plus 16 is going to be 8 plus 1 is 9. So the vertex is negative 2, 9. So any questions on this here? Because again, at this point, we would graph it, and I just use the graphing calculator to find it. Now, we're not going to worry about minimum or maximum increasing, decreasing. We're not going to worry about this. It's just that a function has a maximum value if it's going down. For a parabola, it's going down if both directions, so it's facing down. The maximum value would be the vertex, the x value of the vertex, not the x value, the y value. The vertex would be the maximum here. Or if it's opening up, the y value would be the minimum, because that's the smallest or biggest value. And there's some other properties to it about decreasing, range, domain. But we're not going to worry too much about those there. Now, the last thing we're going to look at is this here. This here is what I call intercept form, because P and Q, the values of P and Q, are the x-intercepts. The value of x crosses the x-axis. So P comma 0 and Q comma 0. So whatever those values are the x-intercepts. They tell us what the x-intercepts are. Now, the axis of symmetry is halfway between these 2 points, and we get it from x is equal to P plus Q over 2. Now, the vertex is kind of the last one. P plus Q over 2, comma f of P plus Q over 2. And we'll see this here, okay? So we're going to look at this here, and it's going to be not too bad, hopefully. So with these here, we want to find 3 things. We want to find the x-intercepts, vertex, and axis of symmetry. Now, the x-intercepts are going to be kind of the easier ones to find. Because again, it says the x-intercepts are P and Q. Well, we find P and Q right here because it's A times x minus P times x minus Q. And again, the numbers that come out for P and Q are opposite of what we think. So the first one is x plus 3. So we have plus 3 in here. So what number is coming out? It'd be negative 3. Because the x-intercept is the value of x that makes y 0, so where it crosses the x-axis. And here we have x minus 1, so the value for this one would be 1. So the 2 places where it crosses the x-axis are at negative 3, 0. And 1, 0. And those are the x-intercepts. It's where it crosses the x-axis. It's the value of x that would make y 0. We can do the axis of symmetry next, because it says x is equal to P plus Q over 2. Well, we've already found the values of P and Q. They're what? What and what? One of them would be, and the other is 1. They're the 2 intercepts. So one of them is negative 3, the other is 1. Well, negative 3 plus 1 is negative 2. And negative 2 over 2 is negative 1. So the axis of symmetry is negative 1. Any questions over anything we've done so far? Any questions over any of this so far? We good with this here? Yes? Still good? Well, the last thing we're going to need to do to find the vertex is, well, we have to plug it in. Because for the vertex so far, we found -1 because we've seen that the axis of symmetry will give us the first value, the x value of the vertex. Now to find the other value of the vertex, I've just got to plug it into our function. So it would be -2 parentheses, -1 plus 3 times -1 minus 1. So I took the original function and I plugged -1 in for x, everywhere there was an x. Well, -1 plus 3 is 2. -1 minus 1 is -2. Well, -2 times 2 is -4. And -4 times -2 is 8. So the vertex is -1, 8. Any questions on this here? You good? Mm-hmm. And then we would graph it, obviously. On most of all these here, we're going to graph it, or really not actually graph it. We don't need a t-table and set of points. But the graphing calculator will do the graphing for us, yes? Are we ready for the next one? Yes? Okay. I'm going to do this one a little bit differently. Grab your graphing calculator. We're going to use it. And what I want you to do is hit y equals and graph this thing. So we're going to go on and graph it. So you're going to go on and graph it. So you're going to hit y equals and type the function in. Yeah. Okay, that's weird. Oh. There you go. Alpha y equals enter, we'll do fractions. Alpha y equals enter, we'll do fractions.
Can you help me?
Mm-hmm.
How do you put a fraction?
Alpha y equals enter. Alpha y equals
How do you do what?
fractions. Alpha y equals.
Okay, but I did it, and I'll redo it, but.
Yep. Yep. So once you finish typing, there you go. So alpha y equals enter. Mm-hmm.
We're not. Yeah, I got the same thing.
Hit zoom. Hit 6.
But it's not the same.
Yep.
That's like a regular.
Hit graph once you get it typed in. Alpha y equals.
Only if you click second. If you don't click second.
Oh, that's what I've been looking at. Oh, okay. X, just alpha, to then find the X.
No, you can just click that button.
Oh.
The button that has X, E, or
Yeah, this one's going to be something different for some reason. It's not wanting to do it. There you go. Get it in. So, okay. I think.
Ian, that's not what we got. Was that right?
Hey, Jason's wrong. Well, look what he did on the board.
It's negative 1/3.
What did I do wrong? Stop. Fraction.
Oh, I know. Okay.
If you want to go back and retype something in, hit y equals up at the very top. Huh? So x plus 2.
Oh.
Guys, and again, we can't use negatives. We have to use minus. All right, guys. So we have this here, guys. Let's focus up here. So we have this here. This is the graph. So if we were graphing this one and picking which one, we can just pick one which one looks like this here. Now we said the x-intercept, so go second table, second graph. And you should get a list of numbers like this here, yes? Second graph.
He goes directly back without messing it up. I push table set.
So second graph. Now, something that looks like this here?
Yeah, it's not the same number.
Well, what x values do you have?
Negative 129.
So it starts at negative 3?
I had 0, 1, 2, 3.
So you can use the up and down arrows to scroll up or to scroll.
I was at 150 something.
Now, what we're using this for is because one of the things it asked for was the x-intercepts. And the x-intercept is the value of x where y is 0. So if we look at this here, I have negative 2, 0. So that means one of the x-intercepts is negative 2, comma, 0. And if we scroll down, so the x-intercepts are negative 2, comma, 0 and 4, 0. Or we could have gotten it from the equation 4 and negative 2. So that's another way to get the x-intercepts. The graph will tell us, or this table will tell us. Huh?
Is it still saying negative 2, 0?
So you can scroll up and down to find it.
Oh, I don't think it's on there.
So scroll up.
It is all the way up. Oh.
Yep. So you can scroll up.
So that's the answer?
Yeah, so those are the intercepts, negative 2, 0, and 4, 0. Huh?
How hard does it go?
It'll go indefinitely.
Yeah, I got to 200. Negative 200. I was already there. I feel bad.
So our x,
Let me see.
so our x-intercepts are 4, 0, and negative 2, 0. And we could have gotten that from the equation, like we did on the last one. But this here also shows it to us. Now, if we look at the graph, and this here is a 1-to-1. So if I notice I go over 2, well, that's negative 2 on the x. Negative 2, 0. Here is 4, 0. Now what we need to find is the axis of symmetry, or the vertex and the vertex. Well, the axis of symmetry for this here is P plus Q. So 4 plus negative 2 over 2. Because I took those two intercepts. So we still have to do this one by hand. Well, negative, or 4 plus negative 2 is 2. 2 divided by 2 is 1. So the axis of symmetry tells me x is equal to 1. And kind of as we've seen so far, it means the x value of the vertex is what? 1, yes? Now, up to this point so far, we would have had to plug 1 back into the function to see what the y value is, yes? So if I go, say, second table, when x is 1, y is, this table will also give you the values. So if you go second table or second graph on the graphing calculator and go to 1, find out where x is 1, it'll tell you what the value of y is for this function. So it means this right here is the vertex. Yeah, so you're there. You just got to scroll.
I just got to scroll all the way back down.
Yep. It'll go indefinitely. So any questions on this here? So this here, this graphing calculator will tell us what it is, but we just have to plug in some numbers first. That's it.